I keep hearing that I should use a box plot to show my data, but honestly, I don't quite get it. It looks simple, but I'm not sure what all the lines and the box actually represent.
That's a very common question. A box plot may look minimal, but it actually packs a lot of information into one picture. The center of the data, how spread out it is, information about skewness, and even potential outliers. And remember, it's used for metric scale data.
So it's like a snapshot of the distribution. Sounds good. Let's get started.
A box plot consists of three main components. First, the central rectangle, known as the box, is drawn. This represents the position of the middle 50% of the data. As you saw in the unit on the interquartile range, these middle 50% lie between the lower quartile and the upper quartile. In other words, the lower edge of the box is at Q1 and the upper edge at Q3. Next, a horizontal line is drawn inside the box to mark the median.
Q2 corresponds to the median.
As a rule, the mean is not shown in a box plot, although it can optionally be indicated within the box using a separate symbol. After that, whiskers are drawn extending upwards and downwards from the box. The range from the lower whisker to the upper whisker represents the normal range of the data. To determine this range, the upper and lower limits must first be calculated. The upper limit is found by taking Q3 and adding 1.5 times the interquartile range. The lower limit is calculated in the same way, but starting from Q1 and subtracting 1.5 times the IQR. The whiskers are then drawn only as far as the last data point within these limits. In other words, the upper whisker extends to the last data value that is less than the upper limit, and the lower whisker extends to the last data value that is greater than the lower limit. Outliers are all values that fall outside the normal range of the data and are shown as separate symbols beyond the whiskers. Right, everyone, let's walk through a real example of a box plot together. We've got data from 9 people's heights. Here's the ranked list of values from smallest to tallest.
So, first step is to find the quartiles, right?
Exactly. For this data set, the lower quartile Q1 is the third value in the list. That's 166 centimeters. The median is the fifth value, 169 centimeters. The upper quartile Q3 is the seventh value, 175 centimeters. Take a moment to check my numbers if you like.
Got it. And in the box plot, the y-axis will show height in centimeters.
Correct. Now we can draw the box. The bottom edge at 166 centimeters, the top edge at 175 centimeters, and the median line inside at 169 centimeters.
What about those lines, the whiskers?
Those come next. We first work out the normal range of the data. We need the interquartile range, the IQR. That's Q3 minus Q1, which is 175, 166, and that equals 9 centimeters. The lower bound is Q1 minus 1.5 times IQR, which is 166, 1.5 times 9, and that equals 152.5 centimeters. So the normal range starts at 152.5 centimeters. Our smallest observation is 156 centimeters, so there are no unusually low values. The lower whisker stops at 156 centimeters.
And the top bound?
Similar formula. Q3 plus 1.5 times IQR, which is 175 plus 13.5, and that equals 188.5 centimeters.
That's where the normal range ends.
The tallest value still inside that range is 177 centimeters, so the upper whisker ends there, a very short whisker indeed.
And if something's taller than 188.5 centimeters?
Then it's an outlier. In our data, we've got one 210 centimeters. We mark that as a separate symbol above the upper whisker. And that's it. Our box plot is complete.
So, to sum up, a metric variable can be visualized with a box plot. First, you draw the box, then the whiskers extending up and down, and finally, any outliers are plotted individually. I like how it shows the spread and that one super tall point at a glance.
That's the beauty of it.